Hey guys, this is 5.4 from calculus. This is exponential differentiation. So if you watched the last video, we did logarithmic differentiation, and now we're moving on to the exponents. So we already saw those rules. So before I start the actual calculus, I'm going to go over a quick recap of some log and exponential rules. So some inverse relationships is ln with e. We talked a little bit about that. Because ln and e cancel each other out, in this situation, whatever function would be in the exponent is what you'd be left with. Same thing here. If e is the base and ln is in the exponent, that would cancel out. And again, you'd just be left with whatever was in front of the ln. So that happens because ln, and again, we talked about this last video, you won't see anything here in the base, but it is understood that it has a base of e. So understanding that there's a base of e here, that would cancel out. Same thing right here. The same exact thing works with logarithms and a base of 10. If you don't see a number in the base of a log, you can assume it is base 10. So for that reason, I don't see anything here. I can assume it's a base 10. This would cancel out, and I'd just be left with whatever's in that exponent. So same thing here. If I had a 10 in a base and a log and an exponent, those would cancel out, and I would just be left with whatever was in front of the log. Okay? Now, exponential rules to remember. A lot of these, you learned these probably back in middle school. Let's just go over a few of them quickly. If I have the same base and I'm multiplying, I can write it as one base and add the exponents. If I'm dividing and I have the same base, then I can subtract the exponents. An exponent raised to an exponent, I multiply. 4 and 5 kind of go hand in hand. If I'm multiplying or dividing and I have an exponent, that exponent can get distributed to both of the values. So again, it belongs to the a and to the b. Same thing with dividing. I can apply that exponent to both numerator and denominator. 6 and 7 go hand in hand. A term can be moved from the numerator or denominator. So notice here it's in the denominator, and here I moved it up with the 1. You are allowed to do that as long as you change the exponent to a negative. It works the same way as if I would have had an a up top and I wanted to bring it down. I would put a negative exponent. So again, here I don't see an exponent. I can assume it's 1. M here represents any number. Like if I would have had 1 over a to the 7, I can bring a up with the 7, but I have to call it a negative 7. Okay? Number 8 is remembering that anything raised to 0 equals 1. 9 and 10 go hand in hand, and it's very similar to 3 and 4 here. 4 and 5. So just like this exponent can belong to both being multiplied and both being divided, remember that a radical is just me writing a fractional exponent, and I'll go over that in a second. So this radical can belong to both of them, right? And same with division, it can belong to both of them. Again, this only works with multiplication and division. So we know that a square root is the same as saying raised to 1/2, and that's because, again, radicals can be written as fractional exponents. N and m represent numbers here. M is an exponent, n is the index of the radical. So the exponent, right, always goes in the numerator, and the index of the radical goes in the denominator. Now that exponent could be written inside the radical or outside the radical, and the rule stays true, okay? So let's go over this quick question here. This is, again, a recap. You've done this in Algebra 2, probably in Trig. So this says to solve, okay? Remember that anytime you have a variable in an exponent, the way you want to get it out of that exponent is by applying a logarithm to both sides, so that I could use that rule that I talked about last class of moving exponents as coefficients. Now, between logarithms and natural logarithms, I like to stay consistent with natural logarithms, especially if I see an e, because I know it'll cancel out. So I'm going to apply my ln on both sides, okay? Now I know, let me color code here, that with that ln, this exponent is going to be able to move to the front, okay? So I'm going to take it slow. If you feel confident in this, feel free to go a little faster. So I have ln of 7 equals, make sure to keep this in parentheses, x plus 1 times ln of e. And we just spoke a little while ago that you do not have to include that ln of e because ln of e equals 1. Okay? They cancel each other out, and 1 times anything is itself. So feel free to draw a line through it. I end up with ln of 7 equals x plus 1. Now for my last step, I just want to isolate this x. So I'm going to subtract the 1. Subtract the 1. Make sure you don't call this ln of 6. That 7 is attached to the ln, where this is just a 1 being subtracted. Okay, so I have to say ln of 7, right? If you want to put parentheses so it's a little easier to see, and then minus 1 equals x. Once you isolate the x, you are free to stop there. Now, I know that seems messier than putting it in the calculator and getting a decimal, but that's probably going to give you some crazy long decimal that the calculator won't even show you every number on it. And the moment we put decimals that we have to round, it is now an estimation of the answer versus this, which gives you the exact value, okay? All right, so now let's talk about the actual derivatives. I'm going to keep showing you these 4 rules together because then, again, I think it's really easy to memorize them when you see them together and their relationship. But right now, we're going to go over the e to the u, okay? So let's look at this first example. Remember, the e to the u rule is rewrite times derivative of whatever's in that exponent, okay? So if I have e raised to 2x minus 1, I'm going to rewrite times derivative of whatever's in that exponent. Derivative of 2x is just 2. And then minus 1, derivative of negative 1 is just 0. So you will always see these numbers, like the derivative of the exponent, written in front of the e. If you would like to memorize this as u prime times a rewrite, that's cool too. That works. But you will always see that be put, especially if it's multiple choice in the front. If it's a free response, you can leave it as is, okay? All right. So let's look at this next one, B. I have rewrite times derivative of the exponent. Derivative of x squared is 2x. And again, you will always see that written in the front. If you feel like these are easy, it's because they are. It's okay. There are easy things in calculus, okay? So now for this next one, I see a fraction in the exponent, and the rewrite will obviously be easy, but then when I have to do the derivative of the exponent, I have options. Quotient rule is obviously an option, but remember that quotient rule is only mandatory when you have a variable in both numerator and denominator. If not, rewriting might be simpler. So for example, I'm going to rewrite this as e raised to negative 3, and I'm going to bring that x up with a negative exponent. And now instead of having to do quotient rule, I'll be doing power rule. Much easier. So now, y prime equals rewrite times derivative of that exponent. I'm going to multiply the negative 1 to the front. It's going to give me a positive 3. And then subtract 1 from the exponent. Okay? Now make sure when you rewrite, I'm going to, again, put this in the front, but make sure that you have all positive exponents, okay? So I'm going to say 3 over x squared times e raised to negative 3 over x to the first power. So I put this in the front. I brought this x to the negative second power down, so I have positive exponent. And then I rewrote this how it was originally, bringing that x to the negative first down to the denominator, so it also has a positive exponent. Okay. Now another way you could see this, like in a multiple choice up here, is this term could be written up here with the numerator. It's another option, okay? All right. So now here, I have sine of x in the exponent. So again, rule stays the same. Rewrite e raised to sine of x times derivative of that exponent. Derivative of sine of x is cosine of x. So you can leave it like that, or you can see it as cosine of x times e raised to sine of x. Either one is fine. Okay, so we went over 4 very simple ones. Now let's see when the rules start to get combined with maybe like product rule, chain rule, quotient rule, and things like that. Okay, so looking at letter E here, I have a function times a function. This is product rule. Okay, so we can call this, let's color code, my U and then my V. Okay, now we have product rule here. So we're going to have U times V prime plus U prime times V. So U is just rewrite e to the negative x times V prime, derivative of sine is cosine, plus U prime. The derivative here we have rewrite, which is e to the negative x times derivative of that exponent, derivative of negative x is negative 1, times rewrite v, which is sine of x. Okay, a few things we can do here. Notice that this negative 1 is going to be multiplied to this term, so this is going to turn into a subtraction. And another option you might see in a multiple choice is that we have an e to the negative x and an e to the negative x. So one option would be to factor out the e to the negative x and then call it cosine of x minus sine of x. Again, just one of many options. Always take a peek at your multiple choice before you keep cleaning so you don't waste any time there, okay? In this next question, notice that there's functions on the inside and then an exponent up top, okay? Hopefully you can notice that this is a chain rule. We have an inside and an outside. So chain rule says derivative of the outside, so I'm going to multiply that 3 to the front. I'm going to rewrite the inside, and I'm going to subtract 1 to be squared. And then I'm going to do times derivative of that inside. So derivative here of 2e raised to x squared. That 2 is a coefficient that I can just bring down. E to the x squared is rewrite. So e to the x squared times derivative of the exponent. So derivative of x squared is 2x. And now we have plus derivative of x squared again is 2x. Okay? So here, this term right here, this binomial, cannot be multiplied with everything else. It has an exponent stuck to it. The only way I could combine it is if I FOILed that. And again, in a calculus test, they don't want you to waste your time with that. So all I would say is maybe combine these 2's right here. And again, always keep an eye on your multiple choice options. You wouldn't want to waste time cleaning anything extra when you don't have to. So I would call this 4x e to the x squared plus 2x. Another option you could have seen is this 3 was distributed into these two terms, because that is allowed because there's only an exponent of 1 here. But again, always take a peek at those multiple choice options. All right, guys, one more question. On this next one, we have cosine of 2x times e raised to x squared minus 1. These are being multiplied, so this is a product rule, okay? So we have, let's call this guy right here our u, times this is our v. So again, we're going to have u times v prime plus u prime times v. So u means to rewrite the first term. So we're just going to say y prime equals cosine of 2x times derivative of e raised to x squared minus 1. Remember, the e is rewrite. times derivative of the exponent. Derivative of x squared minus 1 is just 2x. Plus u prime, derivative of cosine of 2x. Okay, so this is a chain rule. We have cosine, derivative of cosine, I'm sorry, the outside is a negative sign. Rewrite the inside times derivative of the inside, which is 2, and then times v. So rewrite e raised to x squared minus 1. Okay? Well, it's looking a little blurry. Let's see if I can fix that. Okay? So now I have two terms here. I've got a lot going on. I have from the plus sign over to the left, this is all one term, and from the plus sign to the right, this is all one term. The first thing I analyze is that this is going to become a minus, okay? And then let me see if I can find anything common that I can factor out to make this look a little prettier. I do see that I have an e raised to x squared minus 1 on both, okay? And I also see that I have a 2 in both of them, not a 2x, just a 2. So that this can look a little cleaner, I'm going to take out a 2e raised to x squared minus 1 and then rewrite the rest. So cosine of 2x, oops, I forgot this x, so I'm going to write them up front, minus sine of 2x. Now let's take one more peek, make sure we didn't miss anything. I've got the 2, I've got the e to the x squared minus 1, and then left over I had that x, cosine of 2x, minus sine of 2x. And there you go.